Okay, so now we are at the peak of what we are going to get into. And we need to be sure that we understand exactly what a function is. But to be able to understand a function, we need to first know what a relation is. So a relation is basically just a set of ordered pairs, meaning I'm going to have more than one ordered pair. So for example, this is a relation. There's 4 ordered pairs here. We can show relations as tables, graphs, ordered pairs, which is what you had, or something called a mapping diagram. So take a look at the mapping diagram. The left circle are your x's. The arrow is drawn to the right circle, your y's. So in a relation, you have domain and range. The domain is all your x values. It's all the possible x values. We also call those inputs. It's also the independent variable, because as we get into real world situations, it's going to be the variable that determines the outcome. Then you have a range. A range is all your y values. It's all your outputs. It's the result after x. They go together. I put in my x and I get out a y. That creates my ordered pair. And the range is my dependent, meaning it's going to depend on what the x is. So let's go look at this. Here, I have a set of ordered pairs. I personally think in order to find domain and range, it's easy to write your ordered pairs into a table. So if you look, I'm going to write my first ordered pair, 5, 2. Okay. Then I have -7, 1. Okay, my next ordered pair would be 0, 3. And finally, I have 4, -4. I can then take this and put this on a graph. I'd go to the right 5 and up 2 because they were both positive. My next one, I'd go left 7 and up 1. Now my 0, 3, I'm not going to go left or right. I'm just going to go up 3. And finally, my last ordered pair, I'm going to go right 4 and then down 4. So by putting it in a table, look how quickly I can find my domain. My domain is all of my x values. Okay? Typically, we write them in numerical order. If you don't, that's okay, but you're just writing the x's, nothing else. Your range, I just write the y values. That's it. So seeing this, I want you to try this one on your own. Pause now, write the ordered pair into a table, plot the points, and then tell me its domain and range. Okay, take a look here. I got all of these values. Where did I get these from? Well, if you take a look here, this point was -6, 5. This point was 0, -7. This point was 2, 4. And this point was 4, -7. All I did was I identified the point and its ordered pair. I first put it in the table. Once I had my table complete, I can then go write my relation. And from my table, I can pull out all my x's and all my y's. So for something like this, when you're given the points, in my opinion, I would first fill in the table, identify each point, fill in your table, and then go from there. I want you to try that now. Tell me each point. What is its x? What is its y? Fill it in the table. Then state the relation and identify the domain and range. I'm going to be looking for this answer in particular. So now that we know what a relation is, we can identify what a function is. A function is a special type of relation. So it's a certain type where each x value is paired with exactly one y value. What that means is your x cannot repeat. Write that down, highlight that, bubble that in. You cannot have the same x more than once. The y, it doesn't matter. The x can only be there one time. If x repeats, it is not a function. So let's go see what that looks like, okay? So number 5, all you're really concerned with to determine if it's a function is the x values. So all you're looking at are my x's. I have a 6, a -4, a 2, and a -7. Well, therefore, x does not repeat, so yes, it is a function. Okay, well, I'm going to go jump down to 9. You guys can do 6, 7, and 8, but look at 9. All I'm looking at are my x's. None of them repeated. A -2 is different than a +2. They are at different places on the axis. Therefore, yes, it is a function because x does not repeat. So, ladies and gentlemen, you need to answer 6, 7, 8, 10, and 11. You either say yes, because x does not repeat, or no, because x repeats. There's one more way to determine if something's a function. If I have a graph, okay, there's something called vertical line test. Vertical is up and down. Vertical is up and down. I'd write that. What it says is if I can draw a vertical line and it goes through the graph and it only touches once, then it is a function. Let's go see what that looks like. So look here. See how I drew a vertical line? Okay. I can draw another one here. No matter where I draw it, ladies and gentlemen, okay, no matter where it comes in, there is only touching one place, okay? Look, it only touches once. It only touched once. Only touched once. It only touched once, okay? That's how I know, yes, number 12 is a function because it passes the vertical line test. There is only a vertical line test. So please go look at this, try 13 and 14 on your own, and we're going to practice this in class tomorrow. But is it imperative? Look, notice how they disappear. Don't draw lines across. When you have them, we test it and then it's gone, okay? So it's really important that you understand how to identify if it is or is not a function. X cannot repeat.